Hi. So in today's problem, what we'll look at is this matrix algebra question. The question is here. Uh, E is a given matrix 1, 2, 3, 2, 3, 4, 8, 13, 18. And P is also given and F is also given. And they have said that Q is a non-singular matrix. Non-singular matrix means that of Q is not zero. And it's a 3 cross 3 matrix, right? And which statement is true? So such questions can come in the multiple correct section of your JEE Advanced. So we'll learn how to analyze this type of problem. So here the first option is saying F is equal to PEP and P square is the identity matrix. Notice that this 1 0 0 0 1 0 0 0 1, this is the identity matrix. And the other statements talk about that of some of the combinations of these matrices and all. So we look at it option by option. So there is no other way here other than actually evaluating PEP, right? So for option one, you have to calculate PEP, you have to calculate P square, and then you will figure out whether it is correct or not. So what is PEP? So let's do that. 1 0 0 0 0 1 0 1 0. And E is 1 2 3 2 3 4 8 13 18. And again, P again is 1 0 0 0 0 1 0 1 0. So when we multiply, we can either multiply these two and then multiply with this, or you can do these two and multiply, right? So let's multiply the first two. So you'll do 1 0 0 multiplication. I am doing the first two I am multiplying. Okay. So this will become one first one, then it will be two, and then it will be three, and here it will be 8, then 13, then 18, and finally you'll get 2 and 3 and 4. And then we multiply this with 1 0 0 0 0 1 0 1 0, right? That will be my PEP. Again, multiplying the matrices. This stuff is obvious. So we'll do 1, 2 0 3 0. So 1, and then we get 3 2, then we get 8 13 18 here, and 2 4 3. So now you notice we have calculated PEP, and PEP has come out to be this matrix, which is actually F, if you see, right? So PEP is coming out to be F, and let's also evaluate P square. P square would be the product of this matrix with this matrix, right? So that would be 1 and 0 0 0 0, and then it is coming 0 1 0, and then 0 0 1, right? So P square is clearly coming out to be I, right? So what we have done is we have quickly evaluated PEP and P square, and we confirmed that option 1 is right? So let's see how we can use these facts to figure out later options. So what I will do is I have confirmed option 1 is correct. I will just write the result there. So basically, I know already that F is equal to PEP and P square is equal to I, right? So this is known to us. Now this second option is talking about taking the debt of this combined matrix and checking whether it is equal to the sum of the debt of EQ and PFQ inverse, right? So since they're asking us for the determinants of each of these matrices, the combination of these, it will be convenient if we know the debt of each of these three matrices, right? So for example, debt of E will be 1 into 54 minus 52. So 1 into 2 minus 2 into 36 minus 32. So 4 plus 3 into 26 minus 24. So 2. So if you see, this is 2 plus 6, 8 minus, so this is 0, right? And similarly, debt of F, also let's check. 1 into, this is 54, okay, same, minus 3 into, we get 24 minus 26, so minus 2, plus 2 into 32 minus 36, so minus 4. So if you see C again, it is 2 plus 6 minus 8. So this is also 0. So we know det of E is 0, det of F is 0, and we have been told that Q is non-singular. So det of Q is not equal to 0, right? These are the facts that we know so far, and we have to figure out the det of this combined matrix. So let's call it, let's say T. T is equal to EQ plus PFQ inverse, right? And we have to find the det of T. So directly finding the det will be difficult because we have a sum of two matrices. So let's see if we can use some properties. So we'll say let's post multiply with Q on both sides to remove this Q inverse part. So TQ will be equal to EQ square plus PF, right? TQ is EQ square plus PF. Now TQ can be written as, notice that F was PEP, right? From here, F was PEP. So it is EQ square plus P into PEP, right? So P square EP, that is what is coming, P square EP. And we also know that P square is equal to I, right? So P square here can be written as I. So this is EQ square plus EP, right? Great. So TQ is coming out to be E common Q square plus P. So if I take det on both sides, det of TQ is equal to det of T, det of Q is equal to, now on the right hand side, when you take the det of these, it's a product of two matrices. So that is det of E into det of Q square plus P, right? And we already know that det of E is 0. If det of E is 0, this is 0. So that means det of T into det of Q is 0. And if that is true, then since Q det is non-zero, this implies that det of T is 0. Are you understanding how we are getting the det of T? We are not trying to evaluate any matrix. We are not trying to do det here because it is a sum right now. We want it to be in a product form so that we can use the property that det of AB is equal to det of A into det of B. So we post multiplied with Q, we got this. Then you use the fact that F is PEP and P square is equal to I to factorize it like this, right? Once you did that, you can take that on both sides. And you will realize that because that is 0, that of TQ is also 0. Because of that, that of T must be 0 because Q was non-singular matrix, right? So option, okay, we have figured out the left-hand side of option 2, right? Right-hand side, that of EQ, you will realize that that of EQ will be 0 because that of E is 0, right? And similarly, that of PFQ inverse, right? That will also be 0 because it will be that of P into that of F into that of Q inverse, and that of F is 0, right? So we are getting 0 on this side and 0 on this side. So option 2 is also correct, right? Again, option 3, again, we already know that of E is 0. So that of EF cube will be, what is EF cube if you think about it? EF cube is EF into EF into EF, right? So basically, when you take the det of that, it will have det of E as a product. And since det of E is 0, we get this is 0, right? And similarly, det of EF is 0. So option 3 is saying 0 greater than 0, which is not true. So this option is wrong, right? So far we have figured out that option 1 and 2 are correct. Option 3 is wrong. And we know det of E is 0. That is what we know so far, right? Okay. We also know that this whole thing is 0. That we have figured out, right? Now we have to find the trace of P inverse EP plus F, right? So let's think about P inverse EP plus F, right? So we know that P square is equal to I. So P is equal to P inverse. So if I write P instead of this, I'll get PEP plus F, right? Correct? And PEP plus F basically means that this is, let me think. Basically, this is, we already know F is PEP, so we can write it as 2 times PEP. We could also write it as 2F, right? but we can write it as 2 times PEP for now. Okay, so let's look at the other side also. So the other side was what? E plus P inverse FP, right? So other side can be written as E plus P inverse is P. So PFP again. And what is PFP? What was our F? F was PEP, right? So I can write that as, excuse me, E plus P, F was PEP. So I'll write it like this. Like this. So this is P square, which is I, and this is P square, which is I. So this becomes E plus I into E into I, which is E only. So this is 2E, right? So this side we are getting 2E here. And this side we are getting 2 times PEP, right? So, okay. So let's think about how we will find the trace for this. So let me just write here. We can say that we have a property that trace of product. If you multiply some matrix with some number like 2 times PEP, the number 2 can come out here. This is 2 times trace of PEP. This is a property of matrices. You can check, obviously, because trace is the sum of diagonal elements. So if you multiply by 2, all the diagonal elements get multiplied by 2. So you can take that 2 outside. The trace will double basically, right? Now, trace of PEP we have to find out. And we know the property that trace of AB is equal to trace of BA. This is an interesting and nice property. You can do it as a proof. Check it out yourself. Take 2 arbitrary matrices and see if the trace is matching for AB and BA. The matrices don't have to be commutative for this to be true, right? So we can write this as 2 times trace of, instead of PE, I'll write it as EPP. I have written PE as EP, right? Correct. Basically, I'm saying this is A, this is B, should be PA. So that will be PPE. That's the same thing. Ideally, if you write it as AB and BA, you should write it as PPE trace, right? Trace of PPE. Trace of PPE is simple because P square is I, right? So this will be 2 times trace of I into E, which is 2 times trace of E. So basically, you don't need to write it as EPP, I think. It is better to use the property exactly accurately. So trace of AB is trace of BA, and therefore trace of PEP becomes trace of P into PE, right? So that is 2 times trace of E. And the other side, we have already figured out that this matrix is 2 times E, right? So trace of 2E is also 2 times trace of E, right? So basically what we get is that the 4th option is also correct. Notice these calculations, I am using properties of matrices. I'm using the fact that trace of Ka is equal to K times trace of A. And I'm also using the fact that trace of AB is equal to trace of BA, right? These 2 properties are helping us figure out this. And also the fact that we already knew that P square is equal to I, that F is equal to PEP, and those things, right? So the earlier options are helping us figure out the last option, right? So I hope you understood how to tackle these type of problems. We'll see more matrix questions in the upcoming series. We are doing problems for JEE Advanced, next year's JEE Advanced. So anybody who is preparing to write it next year, you should go through this series whenever you have the time. This will help you a lot in your maths. So that's it for this video. There is a link in the description which has a Google form where you can send me your doubts. If you send any of your maths doubts or even a physics doubt, I will try and make a video and try to solve it for you. So please use that option. Also like and subscribe to the channel and see you next time.